Okay, so section 10.5 talks about multiple regression. Okay, so in the preceding sections, we've been talking about all this linear regression between two variables within here. So in this section, we start talking about methods that analyze a linear relationship with more than two variables. Okay, so we talk about finding multiple regression using values of adjusted cap r squared and the p-value of how things measure for how well it goes. So some of the basics. We will consider linear relationships only. Okay, so multiple regression lines can go to many different things, but we're not going to take a look at anything else besides linear within here. Okay, so when we start talking about multiple regression line, we start talking about the simple fact that a multiple regression line is a linear relationship between the response variable y and two or more predicted variables. You know, x, y, or x1, x2, x3, up and up. So we see that we have multiple inputs leading us to one output. You know, for instance, as a doctor, you could be thinking heart disease as current medical conditions. You could be thinking past history in there. You could be thinking family history. So there's more indicators into a prediction of what's going on within this issues. So as our calculator, once again, we're not using the TI-8384. We're using our TI-Nspire CX calculator, but we do have this built-in feature. It's called a multiple regression test. Okay, so we'll have a multiple regression test within here. Now, some of the indicators that go into this is basically what do we have to do as we're doing this. So we talk about our r squared and then our adjusted r squared. Okay, so this adjusted adjusted coefficient of determination. Oh, just here so you can see it. The adjusted coefficient of determination is a multiple coefficient of determination, cap r squared, modified to account for the number of variables and the sample size. It is calculated by using this formula right here. So we talk about the cap r squared, adjusted r squared value equals 1 minus all this value. Once again, we're bringing the actual r squared value into here. Then we'll relate our p-value. So the p-value is the measure of the overall significance of a multiple regression equation. Once again, the p-value of 0.000. It is small, indicating that the multiple regression line has good. So we're going to be testing this as we keep going through. Do realize they're kind of giving us a little introduction into here as we test b1 or beta 1 equals beta 2 equals 0 or not within here is kind of implying what's going on. So our guidelines. Okay. Determination of the best multiple regression equation is often quite difficult and beyond the scope of this section. So this goes so far in depth into what we consider, what can we consider, and what would be the best thing that we would talk about. Kind of going through, they talk about use common sense and practical considerations to include or exclude variables. Consider the p-values. Consider equations with high values of adjusted r squared and try to include only a few variables. Okay, so they give us a little section right over here on this table where they start talking about if we were to let's see here, the story problem talks about data set and includes age, foot length, shoe print length, shoe size, height for 4 different subjects. Use these values in the data. Find the regression that is best in predicting height. So we're trying to predict height. Okay, so if we consider what's going on here, we start considering the fact that we talk about, hey, we want to have this, a very low p-value. So if we see we got some 0.00, 0.00, 0.00, 0.00, oh wait, these are all telling us about the same thing. This is 0.004, so it's really low, but these are lower once again. If we come over here, we start seeing our adjusted R-squared values. Now, once again, these two have the higher adjusted R-squared values. So once again, the higher is going to be that larger critical area. Once again, this is that critical value technique that's going into here. So we would have an adjusted R-squared value that we'd want to be above in relationship. So we see this is very low right here as an adjusted R-squared value. So sometimes that p-value, even though it's very low, this is very hard to determine what's this better, but over here you see 0.1772 to 0.70. There's a large difference in here. That's why this adjusted R-squared is a better way to tell what is the best indicator on here. As we go through, the higher this value is, once again, the closer we are to that 1 for that relationship of linear, the better off we're going to be. But if we notice 0.65, 0.74, 0.75, so really this is the highest one. But do realize this is a little bit higher than what this one was. This is only including 2 variables. This one has 1, 2, 3, 4 different variables. So you have 4 different inputs, where this is only giving us 2 inputs. So that's why they state that this is the best one. And these are not the best ones to choose. Once again, because we want to look at our adjusted R-squared values to see which has the highest value in here. After that, we want to make sure that if some are close, we want the least number of variables. Okay? So the least number of variables is what we're shooting towards in here. So do realize that as we keep going through, there are dummy variables and logistic regression. So we start talking about the values within here. When we talk about this dummy variable, or basically dichotomous variable, which is a variable with only 2 possible discrete values. Okay, so they talk about male, female, dead, alive, cured, not cured. It's so hard to put values on these, but what we start doing is we start incorporating them as a 0 or a 1, and then we call it that dummy variable. Okay, so it's not an actual value here, but because of how we're indicating it, it's giving us some sort of value in between 0 and 1 within our model that's going to help with this. And once again, if we talk about everything being a male or everything being a female or a female, male, however we want to assign it, we're going to see that if everything there we have a 0 or a 1, it's not going to influence our data overall for predictions. Once again, we had talked about logistic regressions in our college algebra, kind of bringing those back once again. In the dummy variable is the response y variable. We cannot use methods of this section. We should use a different method known as a logistic regression. Okay, so once again, logistic regression is a little bit more complicated as we started talking about it. We're going to be dealing more basics, so we do not, this section does not include detailed procedure for using logistic regression, but several books are developed to this topic. Okay, so this is a very key, important issue.